So on Monday, we started the lesson 7.5 handout day 1. So if you do not have a copy of that, please make sure you get a copy of this handout from your teacher before continuing the video. So the first thing we did on Monday was try to figure out which pairs went together in terms of corresponding pieces to determine similar triangles. And so if you were not here, we paired up triangle ABC with the triangle down at the bottom, JKL. They do both share the right angle. It appears they don't share any other angles, but if you find the third angle, which is angle B, it's 54 degrees, and if I find the third angle for the other triangle, it's the 36 degrees. So even though they don't look like they are similar, they actually are similar because they do share all three angles. So we pair these together, we make sure that we match up corresponding pieces. So angle A is the 90, so angle K is also the 90, so that'll be the first letter since A is the first letter. B is the 54, it's the second letter, so the second letter will be J, again both being 54 degree angles, and then L being the last letter. And we talk about the fact that the pattern we're using is either angle-angle, side-side-side, or side-angle-side. The second problem, again, these pictures are not drawn to scale. So we looked at the angle, and we do have the one angle, and we do have a side-angle-side pattern in 5, followed by the angle, followed by the 3, and that's true for the triangle below it. And so if I pair up the two longer sides, and if I pair up the two smaller sides, in both cases I'm getting the same scale factor of 1. So these triangles are similar by side angle side. And again, and this one here we talked about on Monday, I would probably begin with the first letters being the angle. And then I probably would go along one side and decide for the 5 or the 3, and then put in the third point. So I'm going to go along the 5, so E to D is the length of 5, just like M to N is the length of 5. And then the third letter would be F for the first triangle and P for the second triangle. So basically DF and NP being the last two letters, that's the side of the pair of sides that are not marked with blanks. So again, those would be the correspondings. And then the last pair of triangles are similar because by side-side-side similarity. So if I would pair up the longer sides to the shorter, I have 6 to 3, and then 6 to 3 again, and then 4 to 2. And in all cases, these simplify to 2. So all three sides have the same scale factor. Again, this one here, because we have isosceles triangle, there's actually more than one way to pair the letters. So if I start with the G, I probably do GIH. So I would do the two equal sides first. So GI is the equal side, and IH be the other equal side. So for the other one, I would do the same thing with the equal sides. So I can do RQ, and then QS would be the equal sides, or I can start with SQ and then go to R. So there were two possibilities in terms of writing the letter combination. You may have, again, just a reminder, you may have a different order in that, for example, maybe you can start with letter A. Maybe letter A and K are the second letter or the third letter. But what's important is that A and K share the same place. So if I start with A, then that means K has to be the first letter. If A is last, then that means K has to be last. If I put C first, then that means L has to be first. So the corresponding parts do have to match up, not only in the picture, and then the orientation, but also in the writing the final answer. Talk a little bit about setting up the second problem with corresponding sides. I think it's really important to try to get everything paired together. And so the L and the H being the right angles, I put those in that lower left corner. We're not given the hypotenuse in triangle JLK. So what I'm doing is I'm comparing the 16 to one of the other two lengths, since the 20 is not in play here because the hypotenuse again of the other triangle is missing. So the 12 and the 16 would go together as corresponding sides because those are the two longest remaining sides, and the 9 and the 12 go together as the two shorter sides or the two shorter legs. And so this would be the setup in terms of orientation. The triangles appear to be similar by side angle side, and we have to check that by putting the 16 and the 12 together and putting the 12 and the 9 together, and then putting the small triangle here as the numbers on the bottom. And then a couple ways of checking this. I could take my calculator and take 16 divided by 12 and 12 divided by 9. We'll get the same answer with decimal numbers. I could also cross multiply and see if I get the same answer also. And if I take 16 times 9, I'll get 144. And if I take 12 times 12, I also get 144. So I do end up with a pair of sides that have the same scale factor because the cross multiplication shows that. Or if I divide the two fractions, I'll get the same decimal number. So in terms of finishing off the lettering, so L goes to J, that's the side for 12, and then L goes to K, that would be the side for 9. And so in terms of setting this up, I would probably begin with the right angle, so it would be H and L, and then I'd probably go along one pair of the corresponding sides. So I go HI, which would be the side going up, like a height. And that would be LJ, also the height, and then finish off the third letter, G and K. And they are similar again by side and side. Orientation is really important, and we can use orientation to help us figure out the answers for problem 3. So for this problem here, what you're trying to do is look for a special relationship between a pair of triangles, and specifically called nested triangles. We're placing two triangles on top of each other that are similar to each other and that they're sharing a common angle. So anytime we do that, when the two triangles are similar, they're sharing the angle, we're putting the congruent angle in the same place. That makes the triangles nested, and the test again in terms of showing that they're nested triangles is that the pair of segments AB and HJ, in this case, that are parallel to each other, because when I put the orientation the same way, and these two angles here at H and A are called corresponding angles, and those corresponding angles are the same because the triangles are similar. Therefore, AB and HJ segments are going to be parallel to each other. So they're asking in the last page to take a look at the problem and then use the padding paper, place the triangle, one triangle on top of the other triangle, so they're sharing the same letter F in this case, and then try to come up with that pair of nested triangles to fill in the missing information. So, I've got the triangle started, and next to problem number 7, and what they're asking you to do is to find the remaining information. So on a sheet of paper, trace the problems. Make sure you get point F and point F prime are on top of each other. It does also ask you to identify the similarity patterns being illustrated in both problems 4A, 4B, and 4C. So if you go ahead and complete problem 4, go ahead and use tracing paper to copy that pair of nested triangles, very similar to what's being illustrated. Next to problem number 7, try to figure out the missing information for the triangle based on the numbers you're given, and then turn the video back on when you believe you have completed all the way up through problem number 10. So in the first problem, which is problem 4A, the pattern that's being illustrated is a side angle side. So you have the 18 followed by angle F, followed by 39. In the other triangle, the bigger triangle, we had 54, followed by angle F, and then the longer side of 117. So in this problem, they're asking you to find the length of GD and the length of CE. Since the entire length FD is 54 and the smaller piece is 18, what we're looking for is basically what's left of the 54. So if I subtract 54 and 18 to find that difference, GD would be 36. For the second one, again, the entire length is 117, the FC length is 39, so that means the piece of CE is going to be what's left of 117, which is 78. They're asking the question, are they parallel? Because the triangles already begin being similar, and as long as I make sure that the congruent angles are corresponding to each other, then these two sides here, GC and DE, will be parallel to each other because we're going to make sure that corresponding angles are equal to each other. It's asking you to write a proportion using the four numbers, 18, 36, 39, and 78, and try to come up with a proportion that actually would work when you cross multiply. So this is kind of more of an experiment. Let's see if we can figure out the right combination. So for example, if I put the 18 here, and let's say I choose to put the 36 together, since they're both making up FD. And if I would take the 39, for example, and 78, because those two pieces make up the length of FE, would this cross product, if I cross multiply, would I actually get the same answer? So there's more than one answer that will work here, but in either case, when you cross multiply, you should get the same answer. So there's, again, lots of possibilities. Some of them will work, some of them will not work. So we'll go ahead and put a combination here. Let's say I put this 18 to 78. Let's make the, again, smaller over bigger. So I'll put the 36 over 39, making again the smaller number with the bigger number. Where in the first case it was 18 to 36, so smaller to bigger. 39 to 78, smaller number to bigger number. I'm trying to become consistent. So if I cross multiply for the, again, check it, 78 times 18 and 36 times 39, check that pair. And then the other side, 18 times 39, I'll compare that to 78 times 36. Does it work or not? Either pair work or not. So 78 times 18 is 1,404, and 36 times 39 is also 1,404. So this one actually worked. The second pair, 18 times 39, is 702, and 78 times 36 is 2,808. This combination did not work. So there are some that do work, and there are some that don't work. And so one of the things you need to kind of figure out as you're working through these problems is how do I find a pattern that seems to be consistent. So this problem here, I'm just going to kind of color code, change the colors a bit here. So we have an 18, and we have, this was a 36, that total length of 54. So I'm going to make this pair, I'm going to make green, and this pair here that also worked as a blue. So I chose the one that worked. I chose the side that I put the two pieces that meant the entire length together, and then on the other side, FE, I took the two pieces to make the entire length of FE to see if that worked, and it actually did work. And so try to come up with a pattern. This one here is one. There's actually another pattern that will also work, and try to see if that pattern is consistent with the remaining problems. So to ask you to start in problem 11, and do the same thing for 4B, and then later